Alright guys, in this video we're going to talk about Jacobian function. Jacobian function is a function that we are going to later use it in finding the inverse of a functions. If you have a function that you want to inverse it, then as you can see, this is the formula, and part of the formula involves Jacobian function, denoted as J. So let us learn on how to calculate for Jacobian function first. Okay, so let function 1, function 2, function 3 till function n be the number of functions of n variables, where you have several variables inside one function. That is what partial derivative is all about, where you have more than one variables in one function. This is how we calculate for Jacobian function using this system of equations. So to calculate for Jacobian, basically we are going to calculate for the determinant, right? Determinant of the first derivative, of the first derivative of the respected variable. For example, if you have, right, for this one you have u in terms of x and y. You have two variables in function u, you have two variables in function v. So to calculate for the system of equation of Jacobian, right, we can expect to have a 2 by 2 matrix because of the two functions. So you have here the partial u over partial x, partial u over partial y, partial v over partial x, partial v over partial y. This is because you have two variables. Let's say you have x, y and z, then this will also expand accordingly, right? So regarding the arrangement of partial u and partial z, right, in Jacobian, the determinant of the Jacobian is also equal to the determinant of the transpose of the Jacobian. So it also means that it doesn't really matter if you arrange partial u horizontally or vertically. So you can put partial u over partial x, partial u over partial y, partial v over partial x, and partial v over partial y horizontally, or you can also arrange it partial u over partial x and partial u over partial y below, and then start the next column with partial v and partial v, right? It will give you the same result, a Jacobian result. Okay, so let's try to look at exercise 5.5 and try to make sense of the calculation for Jacobian system. Alright, let's look at the first one. Given u equal to xy and v equal to x plus y, determine the Jacobian for the system of the equation. So to determine the J or the Jacobian for this system, as we have discussed before, we are going to use the determinant, right, for Jacobian. So as you can see, this is how I arrange it. I arrange the function horizontally, right, where I have partial u on the first row and partial v on the second row. You can also do based on a vertical, where you have partial u on the first column and partial v on the second column. Okay, it doesn't matter. So now we have this to figure out for the Jacobian function. Simply find all of these components. So let's look for all of these partials. Partial u over x will be equal to y. Then we have partial u over y will be equal to x. Partial v over x equal to 1. Partial v over 1 equal to 1. Right, the next step is to substitute all of the partials inside this system. So then calculate for the determinant, and there you have it, the Jacobian function for this question. And let's look at the next one. Given u equal to 4, y is multiple of x, and v equal to these equations, determine the Jacobian of a system of equations. Alright, everything should be the same. I just expand this to make it easy for me to do all the work later. So find this. So look for partial u over x, right? Partial u over y, partial v over x, and partial v over y. Substitute it in the system, and then calculate the determinant and simplify it, right, to get the function. Now that is the steps in Jacobian, in finding Jacobian function, right? This video serves as the purpose to prepare you in finding the inverse, right? So let's try to find inverse using the knowledge of Jacobian that we have in finding Jacobian function, right? So let u and v be the two functions of two independent variables x and y. For example, u equal to the functions in terms of x and y, and also v. We have seen it before in our discussion in Jacobian function. Partial derivatives of partial x over partial u, partial x over partial v, partial y over partial u, and partial y over partial v are given by these equations. Okay, so notice that the function given is u in terms of x and y, v in terms of x and y. In other words, if you try to find any derivative, it will give you the derivative of u in terms of x, right? You will have partial u over partial x, or partial u over partial y. Okay, the same goes for this one. You will, when you find the derivative here, you will get partial v over partial x and partial v over partial y. In a case where you want to find a derivative like this, where it is the other way around, so you have partial x first, then over partial u, partial x over partial v, partial y over partial u, and partial y over partial v. As you can see, the numerator and denominator is upside down. You will need to conduct an inverse function using this formula, right? So as you can see, to find partial x over partial u, this is the formula which involves j or Jacobian as the denominator. The one that we need to be familiar with is, right, there are two things that we need to be familiar. We know that the denominator will be the Jacobian always, a Jacobian function. We need to know how to determine the numerator. So when you want to look for partial x over partial u, what will be the numerator for it? And the same goes for others. So my simple rule is, when you want to look for partial x over partial u, okay, the numerator will be the inverse of this, right? The complement, inverse and complement. I mean that first you inverse, instead of partial x over partial u, we'll put partial u over partial x, right? And find its complement. So partial u will be partial v, partial x will be partial y. So that will be the numerator, right? Let's check. For this one, partial y over partial u, the inverse will be partial u over partial y, and its complement will be partial v over partial x. Right? You can do that for the other two. So that is how we find out the numerator. And please don't forget one more thing. for each of these, right? For each of these, one of the formula will be negative. So for functions that involve function v, right, you will have negative for this one, partial v over partial x. As for those that involve partial u, you will have the negative on partial u over partial y. Please be familiar with it. Alright, so that is the formula in finding the inverse using Jacobian system of equation. Now, in other words, when you encounter with the question, we'll need to find the Jacobian first, and then we need to find all of these things, all of these partials, to find the partials here. Okay, so let's try to do the question and to see the steps on how to do that. Alright, let's look at this exercise. Let's try to focus on the video that just discussing on this exercise on the next video, right? So for this video, it will just be the concept of Jacobian. Okay, thank you.